when I teach that again, I'll backpedal the same way because I forget, and then I realize that that book thinks you know stuff, and then I'm backpedaling the entire time. All right, so definition of topology. Nakul, you'll recognize this one because I gave it to you in Foundations without telling you what it was.
First semester. That's why I took it. Or what was it? Yeah, it was first semester. Thought it was over.
So I gave them a problem where I didn't tell them it's topology. I gave all these conditions. And I asked them what's in that set, what's not in that set. It was one of their, I think, second week homework.
I still have one.
Show me the coffee cups. Show me toys.
How many holes do I plants have? How many holes does it have?
So this is the weirdest thing, is that open sets are not what you know them to be. So your definition of open set is generalized.
Ma'am, what's the symbol?
It's a scripty T. So it's a, I mentioned that when we have collections of sets, we use scripts. So topology T. And the first condition, so physicists call these check proofs. So if you want to prove something is a topology, you just go one by one and check through them. So the first condition is that these are open. What that means is, by definition, it's an element of the collection of sets. That's what it means. So you have to first show that empty set and the whole set are the elements, not throw out everything in your mind of what you know about open sets. This is the definition of open set. An element in that collection. Definition of open set. So topology is a collection of subsets of this thing, where each of the I missed something. Each should have element. So they're the element of, each one of the elements of T is called an open set. The intersection of finitely many open sets is an open set. The union of any collection, could be infinite, of open sets is an open set. And by open set, you mean that it belongs to the original topology. That's what you mean. It is.
So the traditional definition of open set, like the one we came in here knowing, does that like nest within this and this just?
Think about that. That's a good thing to think about. You can give that as a homework problem. He's not going to open his mouth anymore. No, it's a good, I mean, it's boring. You have to go through and just write. So there's point set topology. I keep talking about point set topology. They start with what you know, which is what you traditionally think as an open set. And to do that, they define something called a metric. You don't need a metric for open set. You need a notion of distance for a metric. So a metric is just distance between 2 points. The absolute value of, if you want to go to the real line, the absolute value of s minus t would be the distance between s and t. That's a metric. Satisfies these conditions. So that's what a typical student would do in a point set topology class. They'd start there and they'd build up. And they would not go to this definition. This definition would be like Hilbert spaces. Somewhere like 3/4 of the way in the class you get the definition of topology. The problem with that is it's just really hard when you go to the definition of topology to imagine anything else, because you spent 3/4 of the class going through stuff you already know, and open was exactly what you thought it should be. And so when someone takes your brain and starts twisting it around and saying, now think of something weird, like, no, I've spent 3/4 of this class thinking of things that are normal. We're just gonna jump off and do weird things right away.
Twisting around, I see what you did there. My brain is a rubber sheet.
Rubber sheet geometry. Okay, so think of this as ingredients that, you know, these are the ingredients that you would need to make topology. That's how I think of these things. So what do I need if I make a collection, if I want to build a topology, what's the minimal thing that has to be in there? If I just want to start for like, the null set has to be in there because of condition 1, right? If I start to like say, okay, I'm a cook, I'm a mathematical cook, got a pot, what has to go in there to make topology? Null set has to be in there. What else? The set itself has to be in there. It's called the trivial topology. You don't need anything more, right? Because the empty set union X is X. So the union of anything in that set is still in that set. And then if I take intersection, the intersection of empty set and X is empty set.
I have 3 rules around this. I don't know what rules around. Crazy. I use this animation.
Sorry, other way around. The open sets are just X and empty sets.
Yeah, the monster video. Yeah, it's like the monster that's like 9.
So the trivial topology is nice for an example. I remember actually sitting, once I had enough training, I was thinking of things like the trivial topology as counterexamples to stuff. So like if you have something that you won't in this book, but if you have something that you want to say, maybe this, they say, if you have a topology, blah, 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 does that work for the trivial topology? And so you'll throw out this example in your head. So it makes a good counterexample. Let's make it non-trivial. What if I just put one subset in there? Okay, why is this not moving? Okay, this is not moving. So what I want you to do is go to take the words and just say, okay, what if I have that plot again, and I throw in my whole space, empty set, and one subset? Just one subset. What more or less, or is it done? Just take words and see like what other ingredients might I need. Maybe I don't need anything. Try it out. You have to go through that checklist. Empty set and X have to be in there. All unions have to be in there. All intersections have to be in there. See what works. If you got that one, if you get that one, try 2. A and B.
Our definition of open set was
Is it element and fractals?
or yeah,
They were using a metric.
okay. I was gonna say it was a little different. So what are the differences between 2 different?
This is the general definition of an open. So when someone says open
I know,
set,
she's out here.
element and a topology. So I would ask, what's a topology? And you know, they hate when you ask those questions, but you know, I see problems in the real world. Like in the microbiome, they look at how to solve one person's microbiome is different than another person's microbiome, and they didn't want to use PCA.
It is a subset.
Metrics.
It does.
So we have a geometry in this, right? Everything makes sense. So if you remove that, they made up their own thing, and it's not a metric.
Intersection and null set
So these don't look like a plot.
The space that didn't contain
And then
I label the report, what we're doing.
and then X.
Life, Roblox.
Alright.
So we need to find to put something else.
Alright, so we need to
I think it's topology, which is one set.
Throw in one subset.
What if you have two? Put A and B.
if we put more sets in.
But it's still gonna be, if B is a subset also of X. I mean, all you're doing, right, is the intersection between B and also the union between B's and also.
But the union with themselves, the union and intersection with each other.
I mean, you add more, right, so A.